Pressurized mudcap drilling is one of the 4 variations of managed pressure drilling, or MPD, recognized by the International Association of Drilling Contractors. Pressurized mudcap drilling is used to mitigate extreme fluid losses, commonly found in highly depleted and naturally fractured formations. In these extreme situations, where lost circulation techniques don't work or are too expensive, pressurized mudcap drilling allows drilling to continue without interruption. Because pressurized mudcap drilling is engineered to inject all the drilling fluid, cuttings, and produce gas into the formation, total fluid loss and kicks are controlled. As a result, difficult or previously undrillable wells are now drillable. By reducing non-productive time associated with fluid loss and major gas influx, pressurized mudcap drilling significantly lowers drilling costs. Costs are also reduced by using water as a sacrificial drilling fluid, instead of pumping expensive fluid systems and lost circulation materials into the formation. In addition, disposal expenses are eliminated because cuttings are injected into the formation along with the drilling fluid. Equally important, pressurized mudcap drilling reduces risk and improves safety because pipe can be tripped and rotated while fluid is pumped down the annulus. Gas percolation and bottom hole pressure are quickly indicated through observation of pressure differences between the reservoir and hydrostatic column, and simply managed by adjusting an annular fluid cap. Pressurized mudcap drilling first places a column of fluid in the casing, drill pipe annulus. This fluid cap is shut in with a Weatherford rotating control device. The dual element RCD is easily installed and maintained to provide a pressure-tight barrier and diversion capability in the annulus. The fluid cap is kept in an underbalanced state with a predetermined surface pressure of 200 to 500 psi. A sacrificial brine or water is pumped through the drill string at normal rates to clean around the bottom hole assembly. Blocked by the fluid cap above it, this sacrificial fluid, along with produced formation fluids and cuttings, is injected into fractures or vugs in the formation. Because all the drilling fluid is injected, a large water supply is generally required for pressurized mudcap drilling. Ideal pressurized mudcap drilling well candidates are those where a high or total loss of returns and gas kicks are experienced. These kick loss conditions typically occur in highly fractured or vugular formations where loss rates exceed 120 barrels per hour. But with pressurized mudcap drilling, these losses mean good injectivity, which is an attribute. Wells without these loss characteristics are drilled using another MPD variation, such as constant bottom hole pressure. Here's the typical scenario encountered with conventional drilling. While drilling ahead, a zone of low pressure is encountered. Pressure exerted by the drilling mud is higher than the formation pressure, and it begins to enter existing fractures and vugs. The driller's first response is to slow the circulation rate and add lost circulation material. If that fails, mud weight is reduced in an effort to match the formation pressure. If this mitigation is successful, drilling continues until a second set of fractures is encountered. Again, mud weight exceeds formation pressure and fluid losses begin. The loss of fluid reduces the hydrostatic pressure, and when it is lower than the formation pressure, gas enters the wellbore and causes a kick. Lost circulation material is added in an effort to seal the lower fractures, which allows the mud weight to be increased in an effort to control the kick from the upper fracture zone, resulting in a new round of fluid loss in the upper zone. This cycle defines a typical kick loss scenario that creates many problems. It increases risk to personnel, equipment, and the well. Fighting the well adds to non-productive time. Costs are increased because of lost fluids and circulation materials. Differential sticking is more likely. Isolating trouble zones with casing reduces hole size, and ultimately, these problems may lead to loss of the hole. In the pressurized mudcap drilling process, a much different response provides a safer, more cost-effective solution. As illustrated in this scenario, as soon as the fractures are encountered and drilling fluid is lost, the well annulus is closed with the RCD. Sacrificial fluid is pumped down the drill pipe, and a fluid cap, often just plain seawater, is injected into the annulus or circulated into place via the casing. With the casing shut in, the weight of the fluid cap is balanced with the formation pressure by managing the surface pressure. Casing pressure and gas migration is quickly and accurately managed through application of surface pressure and by adding or removing fluid from the top of the fluid cap. To continue drilling, fresh water or brine is pumped down the drill pipe. With the annulus closed and pressure balanced, the fluid can't return up the annulus, so it finds the path of least resistance, which is the lower pressure in the first fracture. As this sacrificial fluid is injected, it carries away drilling cuttings and any produced fluids or gas. Reservoir conditions do not affect the fluid injection rate. Drilling continues, and a second lost circulation zone is soon encountered. Because the pressure is higher in this deeper section, the upper set of fractures continues to take the sacrificial drilling fluid and cuttings, and drilling continues without delay. In this manner, pressurized mudcap drilling solves one of the most difficult challenges faced by conventional drilling methods, and in doing so, makes previously undrillable wells drillable.